Hi, welcome back. So in chapter 3, you must know the outline of trigonometry. The idea of trigonometry in the form of this framework, which we call it the unit circle chart, is fundamental in order to actually utilize this piece of information. So what I'm going to do right now is not to teach you how actually to use this, but to understand the story from the very beginning. We need to understand meaning of angle. When two lines join at a certain point, that space between them called an angle. And we could use the number system actually to quantify the value of these angles that we see. Now we have three of them. None of them have this unique property as we saw in here. Both lines were perpendicular. The other two angles just normal angles. To call this kind of angle as a right angle. Somewhere along the line, as it turns out, if you take a normal line and try to bend this line around itself, where to join the end of one point of that line to the beginning of that line in the form of what's called a circle. And as it turns out later on, that the length of that line that joined the circle divided by the diameter, take the ratio between them, pi number, irrational number. And of course, using the property of mathematics, that the length equal to pi multiplied by the diameter. And instead of the length in most of the academic book, we use what's called the circumference. And the radius, as you could see, is just a point from the center all the way to touch the point on that line. Diameter is equal to 2 of these r. I could actually substitute such knowledge with the essential equation 2 pi multiplied by the r. Here, if we'd have two variable or axes, simply you could look at this as what we call in different regions. So here we have got one region, and this is the second region, the third region, and the fourth region. And very important things to observe that in the first region, all the point be positive at the x and positive at the y, whereby the point happens to be in this second region, negative at any value of x, positive at any value of y. Third region and the last and the fourth region, positive value of x but negative value of y. Angle formed in the form of a triangle, and then the circle, and then the coordinate system, all of them put together. Now the quest is to quantify those angles, to give them a numerical representation. And this is where the point was by creating the circle, where the center of that circle is going to be axis of coordinates of both variable of x and variable of y, the origin of 0 and 0, this radius, and set it to the center of that circle, giving this radius value of 1 unit. So at this point here, in terms of x and y, 1 and 0. And if it is here at this point, in terms of x is going to be 0, and in terms of y is going to be 1. And if it is here, in terms of x is going to be -1, in terms of y is going to be 0. And finally, in terms of x is going to be 0, in terms of y is going to be -1. Well, if I move the radius only up to this point here in region 1 here, in terms of x and y, it will have a positive point. But how about the value of this angle? Well, I think the point was to start from a reference point, system of degree. So you could choose a number here, x, and give it this upper script of degree, and this value of x will represent that much quantity of this space, or we call it the value, starting from 30. So I know this is the angle of 30, and it looks like this. How about maybe this point? Just you start to add another 30 to it. It means this is going to be 60 degree. You could see now I am reaching to that unique right angle I was talking about, 90 degree, and so on. So I could have moved all around the circle with the final quantity of 360 degree. If you look at this area, what I have just formed here, half the circle here, I have 6 different regions to cover entire circle. It means +6, it means should be 12. A new proposal to measure the circle at the middle somewhere here, and we will call it a 45 degree. And just to start adding a different point as you are moving across the circle to have the final again 360 degree. But the difference here, at every region 1, 2, 3, and 4, we have only one point as a reference of the angle. But in terms of the 30 degree, we have 2 reference points. Now, in a much clearer and better way, you could see it quite clear here. That much, it is a 30 degree, right? And that much, is a 45 degree. That was the first kind of system was actually established or built to measure the quantity of an angle. So for example, if I would have a triangle, if we call this angle as theta, three names, you must be very much familiar with them. Giving theta, there is the opposite to theta, and there is the adjacent to that. And then the right angle, always the one opposite to right angle, is called the hypotenuse. If you take the length of that opposite and divide it by the hypotenuse, you will get a number here, value 1. And then if you take the adjacent to that angle and divide it by the hypotenuse, you will get another value, we call it value 2. And then if you take the opposite of that theta angle and divide it by the adjacent of it, you will get another value, I will call it value 3. But there's a very important piece of information. No matter what is the length of that adjacent, opposite, and hypotenuse, as long as the angle is 30 degrees, you will always get the exact same number. If you try on your own, the adjacent here, 129.90 divided by 150, that get you to 0.866. Let me again change the length of the hypotenuse to be, for example, 15. If you take again the adjacent, 12.99 divided by 15, you will get again the same value. How about if it is 60 degree? Divide the opposite, which is 4.33 by 5 with the hypotenuse. We are getting a value of 0.866 as long as the degree is 60. And that was the sine of a theta, cosine, and the tangent, they call the opposite over the hypotenuse. The cosine is the adjacent by the hypotenuse. Finally, the tangent, the opposite over the adjacent. Integrate these three different functions to their reciprocal function, cosine or CSC, 1 over the sine of that theta. Reciprocal for the cosine function, we call it the sec function. And finally, the cotangent. And you could see in this table actually that if you look over the number of degrees, starting from degree 1 all the way to degree 90, which is a right angle here, if you move somewhere around the degree of 30, which is somewhere around here, right? We have seen previously that no matter what was the length of the adjacent, the opposite, or the hypotenuse, for that theta angle, we'll always get the sine of theta, the opposite by the hypotenuse, where I will always get 0.5. Cosine of theta, that means the adjacent of the hypotenuse, I will always get 0.866. And the same thing for the tangent, you will get the value 5774, something like that. Now, if I look at theta angle here, this is the opposite, which is related actually to the measurement of y-axis. And if I look at theta at its adjacent here, it is actually related to the x-axis. In other words, what I want to say, that opposite, it means the y-axis, adjacent means the x-axis. So if I want to rearrange the writing of these two functions down here, I could simply say, you can see that the opposite, it represents actually a point of y. The adjacent also can be represented as the x point, which is down here, right? Now, since we established this piece of information, let's get back to our circle that we established all the degree around it. This point is actually, again, could be represented by x and y. If I look at the end of this point and I drop a line just like that, I have a right angle of this triangle. The opposite of it, which happens to be the radius. Now, if I look at this angle, which is going to be the reference of 30 degree, it is my theta. It means this side is going to be my opposite and this side is going to be my adjacent. But don't forget, there's something interesting about this circle from the very beginning. We said we are going to imagine that the radius is equal 1 unit. It means the hypotenuse here is just equal to 1. Now, if I want to substitute what I know here, that y is equal sine of theta multiplied by 1. It's same for the x, which is the adjacent, is equal cosine of that theta multiply again by 1. Now, if I want to substitute this value here, instead of x and y, I could easily say adjacent and opposite. Or I could say this is a cosine value of theta and a sine value of theta, which is 0.866 y, which is represent 0.5. And just actually by eyeballing, you could see in terms of the x, I am quite close to the 1. At the y, I am somewhere in the middle. Now, instead of using these decimal kind of representation value, usually in most of the books, you will see that there is another way of representing these numbers. Some of them you will see very soon, they are actually irrational number. And that is actually through the use of the following. Large number is equal to root of 3 by 2. Medium number is equal to root of 2 over 2, and small number root of 1, square root of 1 over 2, which is literally equal 1 over 2 or half. We're going to substitute these values. Now, when I am at 30 degree, seems that the x is very long, but the y is very small. Now, when I am at the 45, seems the length of x and y somehow to be equivalent, I mean at the medium size. But when I am at 60, now the y is long, but the x is small. But the only difference, you don't forget that our system here in this region, all the value of x and y have to be positive. Here, x is going to be negative, y is going to be positive. Here, x is going to be negative, y is going to be negative. Here, x is going to be positive, y is going to be negative. This is the only difference. Now, if I get back to the original circle here, I've established almost the entire fundamental understanding on the framework of unit circle chart. Lastly, we have just left with the one number that exists on the circle. We need to understand its story. So we know the 30 degree, the 45, we know those points and everything on the circle. Left to understand this, the use of pi and how it comes from. Now, to understand that, we need to get back to the idea of circle. Now, I'm going to take this piece of information and I will rely on it. If you remember, our unique circle here has some important property that we established from the very beginning, and that is the value of the radius is going to equal to 1. It means this unique circle have a length or a circumference of a value of 2 pi. In other words, if we want to visualize that, if I am at 0 point here and I move all the way around the circle, it's stopped at 2 pi. To quantify the angle in terms of the radius. This is the new system, we call it the radius system. Actually, if I want to turn all the way around the circle up to this point here, I have this large angle and I want to quantify by the measurement of radius. I could look at the value of 2 pi, and it's obvious to see it is a 2 pi. Half the circle, it will be pi. Now let's look from a 30 degree perspective first and then a 45 degree perspective. Now if I look from 30 degree perspective, if you remember, I have shown you that 6 different regions. So let's start with the first region corresponding to the 30 degree. Now if I am at the first angle here, 30, 1 over 6 on the total using the pi system, 60 degree. The second reference point, 2 pi's over 6, 1/3, want to reach to the pi here as if I covered all the 6 pi's, and that's correspond actually to 6 pi's over 6 pi's, that is 1 pi. If we start to the second half of that circle, I am here at 2, 10. So I get 1 and 1 over 6 is equal 7, 6 of that pi, and so on and so forth. Same thing, actually, we can use the 45. However, the difference here with 45, I get only 4 regions. Now, if I am at 45 degree, that is equal 1/4 of pi. Same thing you do when you finish 1 pi, you start the other. Now, if we want to translate this, the 30 degree correspond pi over 6, and then 60 degree pi over 3, and so on and so forth. You keep moving that way. I want to show you, closing down on this entire section, degree of 0, my sine is 0, cosine equal to 1. Now we are actually ready to move to the third outline, and that is the E mathematical constant or the natural logarithm of ln. I'll see you then.